Welcome in the class of engineering hydrology. Today we are going to discuss different methods of reservoir routing. So, first one method is a modified pulse method and next one is Godrej method. So, in last class I told you the basic concept of routing, and I told you that we have two cases. First one is reservoir routing and second one is channel routing. So, in reservoir routing, we are in reservoir routing, say this is the situation of reservoir and this is the initial water level, and the reach it is one section 1 and section, this is section 2. Okay. If in flow hydrograph means input hydrograph is entering at section 1, then water, some part of the water is stored, okay, is stored, and after storing the water is coming from section 1. So, this is input and this is outflow, okay. So, we need to predict, we need to find this Q, and storage, okay, and storage at 2. Okay, we need to find two things. Q, okay, Q at section 2, okay, and storage at section 2, okay, at section 2. In modified pulse method, continuity equation has been used. As I told you in my last class. Okay. So, what is continuity equation? Continuity equation is input, okay, minus outflow, inflow minus outflow, it is equals to change in storage. Okay, change in storage ds by dt. Okay, since I and q, the unit of I and q, it is in meter cube per second, that is why ds by dt. Okay, and for significant time interval delta t. Okay, so it will be I into delta t minus q into delta t. Okay. That will equals to be change in storage, means S2 minus S1. Okay. This is continuity equation. That I have told you in previous class. Okay. And say at time t1 and t2, say at a small time interval delta t, at a small time interval tt. So, this is what? This is I1. This is I1, and this is I2, and I told you that we will take average of I1 and I2. You will take average of I1 and I2. Okay. So, this is I1 plus I2 by 2 into delta t plus Q1. Similarly, outflow, this is, if this is inflow, and outflow, if outflow is this one, okay, if outflow is this one, so outflow means this is q, this is q, this is q1, and this is q2. Okay, this is q2, right. This one is q2. this is Q 2. So, and same we will take average of Q 1 plus Q 2 by 2, means Q 1 plus Q 2 by 2 into delta T is this one. Okay. What is known to us? What is known to us? Known parameter, it is I 1 is known, I 2 is known. Okay. Input hydrograph, okay, I 1 and I 2 at time at time T 1 and T 2, okay, that is known to us. Okay. And Q 1 is also known to us, Q 1 is also known to us, okay, Q 1 is also known to us, okay, at section 1, okay, at section 1 here Q 1 is also known to us. Q 2 that we need to predict, this one that we need to predict. Okay. S 1 it is also known to us, it is also known to us, okay, because the storage within certain duration, it is the the quantity of the water entering at section 1, it is S 1. So, S 1 is known, and S 2 the quantity of the water stored at section 2, okay, stored at section 2, that is not known. Okay. So, the known thing, so by writing the known thing on left hand side, okay, so we will get this one expression and this one S 2 plus Q 2 into del T by 2. So, this right hand side, it is unknown, and this one is known, this one is known. So, by putting by knowing this with the help of that equation, right hand side part can be calculated. Okay. And here S 2 and Q 2, okay, we have two parameters, and in last class I told you how to establish a relationship between storage versus H is the depth of reservoir, and Q versus H. Okay. That expression has been understood with the help of one example. So, we have this one relationship, okay, and that one value we can calculate with the help of the input data. Therefore, the value of Q 2 and S 2 can be calculated with the help of this phenomena, okay, and that procedure has been proposed by the Puls, okay, that has been proposed by the Puls. Okay. In Godrich, the same equation is being used, has been used, and but the difference is that this one equation, okay, this one equation has been multiplied by 2 and divided by del T, then left hand side is this one and right hand side will be this one, okay, and we are doing the same procedure as in this method. Okay. So, the same thing, okay, except the multiplication and dividend parameter is different. Okay. So, in modified Puls method, what will be the step? Step number 1, for the first time interval delta T, for the first time interval delta T, okay, I 1, I 2, S 1, Q 1, it is known. Therefore, S 2 plus Q 2 into delta T by 2 are determined, step number 1. And step number 2, from the relationship of S plus Q into delta T by 2 versus H, okay, since this is known to us, that's why that S plus Q delta T by 2, that will be the function of H also, and therefore, H is find out, okay, and at the same time from the H outlet discharge is find out using discharge elevation relationship. Using this one relationship, we can calculate the discharge. Okay, we can calculate the discharge at particular depth, Okay. In step number 3, okay, for the next time interval, this one parameter S1 minus Q1 into delta T by 2, okay, at the beginning is found from this one expression, for next increment. Okay. So, this one parameter will be this. Okay. This one parameter will be this one. Okay. Q2, what is Q2? Q2 is the discharge which has been calculated in step number 2. Okay. In step number 2. Okay. And after doing that, we will repeat the procedure. Till the entire inflow hydrograph is routed. Okay. So, these are 3 steps. Okay. And with the help of example, I will explain the procedure of storage routing. Okay. This is the questions, and the question: storage discharge elevation relationship for a reservoir is as follows. Okay. In last class I have calculated, the table was was prepared through the data, through the survey data given in the question. So, this is known to us. Okay, this is known to us. Okay, through survey that data can be prepared. Okay. And here it is storage, it is relation, it is the function of H, elevation, and discharge, it is the function of H. So, at different elevation means at different elevation, say if 470.8, if H is equal to 470.8 meter. Okay. If we need to calculate the storage, okay, then it will be less than 51.62. Okay. That storage can be calculated with the help of these two ordinate by interpolating. Similarly, the discharge can be calculated with the help of interpolation of these two data. Okay. So, that data is given, okay, for the reservoir characteristics. Okay. And flood passes through the reservoir. Okay. This is the input hydrograph, this is the input in inflow hydrograph. Okay. Time and flow it is given, and the duration is for 6, okay, 6 hours, 6 hours. Okay. So, okay, storage is given in days, actually storage is given in days. Therefore, time in days it will be 6 hours means 0.25 days. Okay, 0.25 days. Okay, 6 by 24 means 0.25 days. Okay. So, we will use the same the steps which I had been told you in previous slide. So, let us make a table. Okay. We need to make a table. Okay. And in this table we will calculate this one and this one. Okay. We will calculate this one and this one. Okay. As mentioned here, okay, S1 minus Q1 del T by 2 plus S2 plus this one. Okay. That parameter we need to calculate. Okay. So, how it will be calculated? It is very simple. Storage at different storage. Okay. At different elevation, storage and discharge it is given. Okay. It is given. Okay. Here it is given. Elevation 470, it is 0, it is 0. Okay. 470, at 470 it is 0 0, at 472 it is discharge 49.2. Okay. 49.2 49.2 and the storage 51.62. Okay. So, it is arranged in the same manner, and that data S plus Q into delta T by 2 and S minus Q into delta T by 2, that we need to calculate, that we need to calculate. Okay. After calculating this, okay, in step number 2, that data will be used, okay. So, this one 57.77 has been calculated, taking S, taking S storage as this one, okay. This is storage plus Q is this one 49.2, delta T, we know delta T here it is 0.25, So, this one 0.25, okay, we get 57.77. Similarly, this one data that is calculated with the help of this storage S, okay, that is storage S plus discharge value 69.6 divided by 2 multiplied by 0.25 and we get the value 114.37. Okay. Similarly, other data has been calculated, okay, and other data can be calculated using same procedure. Okay. S minus Q into delta S minus Q delta T by 2, it is calculated, okay, here, okay, this one, okay, the only the difference is minus, okay, everything is same. So, it is 45.47 for at different elevation, it is 96.97 and other values can be calculated in same manner. Okay. So, this is the table 1, okay, this is the table 1. Okay. Actually, why the table has been prepared? The table has been prepared to get the elevation, at known quantity of this one values. Okay. Okay. So, we will make another table, and that table according to the procedure proposed by modified pools. Okay. So, this is I1 I1 plus I2 by 2 in del T, okay, this one, and this is summation. Okay. So, time it is given, in flow it is given, in the question, okay. At time t equals to 0, what is the value at time t is equal to 0? Flow is 50, at 6 hours it is 180, okay. So, that is mentioned here 0, 50, 6, 180 and so on. I1 plus I2 by 2 into del T, okay. Then S1 minus Q1 into del T by 2, okay. So, this parameter is known to us, and S2 plus Q2 by 2 into del T, that we need to calculate, okay. And at different and elevation, okay, that has been calculated with the help of the elevation, okay. Once the elevation is known to us, the discharge can be calculated, okay. Let us make how different values has been calculated. So, first of all take consider this value 28.7, it is simply I1 plus I2 by 2, means this is 50, this is inflow, means I1 value is this, I2 value is this, divided by 2 into delta T. Del T is here, it is 0.25, okay. So, you will get this one value, okay. Similarly, 56.25, okay, I1 and I2 will be this one value, okay. For these two values you will get this one, okay. S1 minus Q this one, okay, S1, okay, that value will be calculated, okay, S1, okay, storage this is what, this is the storage at section 1, okay. So, in question in question, find the flood hydrograph after after routing the outflow from the reservoir just before the flood was how much 200 meter cube per second. Okay. At 200, find the flood hydrograph after routing if the outflow from the reservoir means the value of Q1 is the value of Q1 is given to us, Q1 is equal to 200, and Q1 is equal to 200 meter cube per second, and at this discharge, this will lie here, this will lie here. So, and here we need to calculate the elevation, at this discharge, that elevation and this storage that need to calculate. Okay. So, the elevation at this discharge that has been calculated, elevation it is 481.3, So, it is 481.3. Okay. This is the elevation, and the value is this one value is this one, okay. This 278.661, yeah, 334.65 and 278.61. Okay, these two values has been used. Okay, so this one. Okay, Okay, so the value in between value is 315. Okay, so that these two values has been calculated for Q1 is equal to 200 meter cube per second. Right. So, this one data has been calculated, 315 has been calculated, by interpolating, at this one, means this. So, at this, if we know this value, then S2 plus this one the data, it is the summation of these two, and if we know this value, then elevation can be calculated, and that elevation at that storage elevation will be what? Elevation is this one, this one 481.3. Okay. So, at this storage elevation is at this storage elevation is this one. Elevation again we will calculate the elevation. So, we will get 480.83 by interpolating. Okay. And at this elevation, what will be the discharge? By interpolating, we will get 167.3. Okay, as explained here. Okay, see this one. Okay, from the modified pulse method, S2 plus Q2 into del T by 2, this one. Okay, and this is the that has been calculated, and corresponding discharge from table 1. Okay, it is interpolated. It is linearly interpolated, and we got 167.3. Okay, we got that value. Okay, next we need to find this one value. Okay, 301.925. Okay, this one value, how it will be calculated. Okay, this is the step number 3 that I have told here. This is the step number 2. Okay, we did step number 1, we did step number 2. Okay, this step, step number 3 we need to do. Okay, means S1 plus Q1 into del T by 2, that will be calculated by this S2 plus Q2 into del 2 by 2 minus Q2 del T, okay, that from here it will be calculated, that parameter will be calculated. So, 301.925, okay, that has been calculated, that has been calculated, that has been calculated just 301.925, okay. Yeah, this one, okay. S1 minus this one parameter, okay, that has been calculated, okay. Previously we know this value minus Q2 into del T, okay, that has to be subtracted, okay. And what is this value? 343.75, 343.75, this one value, okay, S2 plus this one, okay. So, this is S2 plus, so this is this is S2 plus Q2 into del T divided by 2, this value minus Q2 into del T, okay. Okay, right. So, okay. So, 301.925, okay, that is calculated. So, this is the value, okay. And by knowing this, this column can be calculated by simply adding these two, okay, adding these two, 56.25 plus this one. So, then we will get 358.75. So, once this data is known to us, then what we will do, we need to find the corresponding elevation, from table number 1, means from table number this, okay, from this table, okay, from this table, okay, from this table, okay, from this column, okay, we will know the corresponding elevation, okay, we will know the corresponding elevation, and the corresponding elevation is 481.15. Once we get this elevation, then the corresponding discharge can be calculated, and corresponding discharge from this one and from this one, okay, by linearly interpolating, and all the data, okay, then in next step we will calculate this one, then this one data will be summation of this one plus this one, okay, and from this data we will calculate the elevation, okay, and from table 1 we will calculate this one, okay, again we will calculate this one, okay, then this and okay. So, this is the procedure to complete the table, okay. So, this is the inflow and this is the outflow. So, this is the for the flood has been routed, okay. Now, okay, so we can make the plot, input hydrograph, okay, from this, okay, this is the discharge versus time, okay, and we will have this type of okay. So, this peak we can calculate the annuation, lag time we can calculate, okay, So, this is the procedure how to reservoir, how the flood can be predicted in reservoir, okay. So, these are the references, and thank you for the listening, and in next class we will start channel routing, okay. Thank you very much.